We'll kick off our two-part sequencer masterclass by creating a two-part bass and hi-hat rhythm using voltage modular nucleus. As ever, the first order of business is to clear the rack with the New button in the upper left corner. Our patch will ultimately contain multiple individual elements, so let's start with a 6-input mixer module. Let's get to work building a suitable bass part. For that, we're going to need an oscillator, so we'll grab one and set its range to 32 feet. We'll want to control it with our MIDI controller as we're designing the patch, so we'll run a cable from the CV source's pitch output down to the oscillator's pitch CV input. Any decent analog bass patch is going to need a filter, so we'll grab the filter module from the library and stick it somewhere to the right of the oscillator. We'll be using our oscillator's square wave for the patch, so we'll route a cable from the oscillator's square wave output over to the filter's audio in jack. We'll need an amplifier, and an envelope generator to control it. We'll run a cable from the CV source's gate jack down to the envelope generator's gate in. We'll run a cable from the envelope generator's positive output to the amplifier's CV amount jack, and we'll run another from the amplifier's output to mixer channel 1. We'll complete the signal path by stretching a cable from the filter's low-pass output to the amplifier's input and the mixer's master out to the main out's 1LM jack in the top panel. We can now play our patch. We'll shape it by reducing the filter's cutoff and increasing its resonance. The envelope's sustain slider can be reduced and its decay and release increased. Now that we've got a suitable bass sound, we'll add an 8-step sequencer from the library. We'll put it in the row beneath our existing modules. The sequencer has 8 sliders and buttons, each representing the state of a step in the pattern. Each step provides a gate and triggers and a voltage. We'll run a cable from the sequencer's gate out to the envelope's gate in. Now if we push the sequencer's start button, we'll hear a steady repetition of the bass sound. You might want to disconnect the envelope's gate in from the CV source's gate. At this point, the sequencer is not controlling the pitch. For that, we need to run a cable from the CV output to the oscillator's pitch CV input. Now we need to make a choice. Do we want to be able to transpose the sequencer's pattern via MIDI? If so, we'll leave that CV source's pitch jack routed to our oscillator alongside the incoming sequencer CVs. We're going to choose that option. So with that in mind, we'll use the sequencer sliders to program a little pattern in C minor. Programming in C or C minor makes it easier to transpose by hitting the desired root key on our keyboard. Our pattern contains a note on each of the 8 steps. We can change this by switching off the illuminated buttons above each slider to provide a rest for that step. Our pattern is a bit slow, so we'll increase its sequencer rate to 60 BPM. Note that you can use the up-down buttons near the top of the sequencer to reduce the number of steps played. 8 steps are good for our purposes. We'll add another sound. We'll install a noise generator. We'll install another filter. We'll grab another envelope generator. And we'll grab another amplifier. We'll route the noise generator's white noise to the filter's audio in. We'll route the filter's low-pass output to the amplifier's input. The envelope's positive output should go to the amplifier's CV amount. We'll patch the new amplifier's output to the mixer's second channel. Now we'll add another 8-step sequencer. We'll route its gate out to the new envelope generator's gate in. We'll start the sequencer. Now we'll tweak the filter's cutoff and resonance. And we'll tweak the envelope sliders until we have a reasonable facsimile of a hi-hat. We'll increase the sequencer's rate and use the switches to create a decent hi-hat pattern. Now let's get our sequencers into sync. We're going to add a third sequencer. This one will act as our master clock. We'll set its rate to 60 BPM. We'll click the EXT for external button on the slave sequencers. We'll patch the clock sequencer's trig out to each of the slave's EXT clock jacks. Now we'll run the master's trig output to each of the slave's start inputs. We'll press start on the master, and that will kick it all into action. This is just the start of what you can do with Cherry Audio's Voltage Modular Nucleus's sequencer modules. We'll explore a little bit more in next month's issue.